Hi students. Okay, before we start working on the factoring stuff, I want you all to understand why we're doing the factoring stuff. So when we're talking about quadratic functions, right? Quadratic functions, we're always talking about a parabola, this shape right here, a curved line. And typically you're going to see the quadratic function in standard form looks like this. Sometimes there'll be the invisible 1 attached to the x squared. Sometimes there'll be a different value than 1, but it'll be ax squared plus bx plus c. And this value c right here is always going to serve as the y-intercept. The y-intercept is where it touches the y-axis. So the y-intercept is the constant, the number by itself without the x, is the y-intercept. Okay, so in standard form, we can find the y-intercept. In factored form, we get what's called the factors. These factors are also called roots or zeros. They mean the same thing. They're all talking about where the parabola touches the x-axis. So they serve as x-intercept. So factors serve as x-intercepts. This c value right here serves as a y-intercept. Where it touches the y-axis, so this is the y-axis, this is the x-axis. Okay. So for this particular function that I've drawn, although it's not great, is this function right here. X squared subtract 6x plus 5. Notice this plus 5 is the y-intercept, and that's where it touches the y-axis. And then if we are to factor that, factors of 5 that add up to -6, there we go. X subtract 5, x subtract 1, -5 times -5, multiply to be positive 5, but -5 plus -1 add up to -6, and then we can find our factors. So the opposite of -5, x will equal 5. The opposite of -1, or the inverse, additive inverse, is positive 1. So those factors, or roots or zeros, where it touches the x-axis. And if you notice a parabola, as it comes down here to the vertex, the lowest point, if you look left and right, the graph is symmetrical. And it is divided in half by this invisible line right here called the axis of symmetry. The axis of symmetry is a vertical line. Remember, vertical lines are in the form of x is equal, right? X is equal to wherever that's touching, whatever value that x number is, that's the vertical line. And to find the axis of symmetry, you find the x value of the vertex, and that will give you the axis of symmetry. So in standard form, let me cover some of this stuff back up. In standard form, you can find this axis of symmetry by doing this. To find the x value, you're going to take the opposite of the b value's right here, the opposite of the b value, and you're going to divide it by 2 times the a value. So here we have our a, which is, shouldn't have just done that. That invisible 1 is our a, this -6 is our b, and the 5 is the c value. Well, the opposite, so if we want to find the x value of the vertex, the opposite of the b, which is -6, divided by 2 times the a value, which is 1. Well, the opposite of -6 is 6. 2 times 1 is 2. Well, x will equal 3. That is the equation of the axis of symmetry. So we know that's our x value right there. Well, to find the y value, find that y value right there, you just plug the x value, substitute it in for the x's. So let me cover some of this stuff up. So to find the y value, to find that vertex point, we're going to say y is equal x squared minus 6x plus 5. And where those x's would have been, we put the x value. So y is equal, well, 3 squared is 9, subtract 6 times 3 is 18, plus 5. And then you just do the math. 9 subtract 18 is negative 9. Negative 9 plus 5 is negative 4. So where that y is, we can move that y out of there, and we can say, oh, the vertex is down there at negative 4. And there we have all the parts of a quadratic. If you know where the vertex is, or if you know where the factors are and the y-intercept, you can sketch the graph of any quadratic. All right, that's it for this.